somewhere. The whole idea for solving hard questions, you can just check first step how we translate the information. For example, they give you something about y, x, dy, dx, right? Now, Cameron, what's the dy, dx?
dy dx equals 2y of x over y.
Very good. Plus x over y, which is just 2 plus x over y, huh? But yeah, doesn't matter. We just keep here. Now, AS knowledge. Perpendicular. If two lines perpendicular, how about the gradient?
Negative.
Yes, which means for G, dy dx equals negative y over 2y plus x. Okay? Any question up to here? This is for fx. Satisfy here? Cameron? Gx is about here. You understand the idea? But you just use y, okay. Now, the question asks you solve for y. Hello? Normally, in our syllabus, if you solve for y, it's called solve differential equation, right? But this differential equation, you cannot separate the variable. Because separate variable, always you have something x, something y, so you can rearrange, you can separate the variable. This way you cannot separate variable. That's why the question give you hint. They ask you, you may find this way useful. Substitution probably useful. Why substitution probably useful? Let's have a look. Check. Check how we use it, guys. Bruce. Why they say this one useful? Let's have a look together. Check. For example, if we just check the part on the right side, if we follow this one, you can just say x equals zy, right? Which means here got negative y over 2y plus zy, which is just negative 1 over 2 plus z. There's no y. Okay? Understand this step? No y. The right-hand side. If you use x equals z, y just got canceled. Let's double check the right-hand side. The right-hand side about dy dx. The right-hand side. So you have dy dx just equals 91 over 2 plus z. Okay? Yeah. Now it's time to change this part. Let's check this part if we can change it. For example, if you differentiate with x, we got 1 equals z differentiate, y no change, z no change, y differentiate. Okay? Check the idea because we try to rewrite dy dx, or we just say like this. Now, dz dx, not sure, we just copy down. Y just x over z. Dy dx just negative 1 over 2 plus z. Check what we did. We just did substitution. This part just here from the previous question. And this y just x over z from the original. So the whole idea pretty much just substitution. Up to here. Can we do something? Make a dz dx the subject. And any question here? You make this part the subject, so move the other part to the left, make it positive. Now, all times by z, or just common denominator. Oh, just rewrite as a single fraction. Because after here, we know we can split the variables. It's called the separating variable already. Okay, we can separate variable, dz dx just equals times by z divided by x. That's dz dx, like dz dx here. Anyway, up to here, you can separate the variable. So 1 over x dx, 2 plus z, z 2 by 2z. Hey, variable separated already. Oh. Yes, partial fraction. That's a 2. 2 you can take it out. Just 1 plus 1z. That's why here 2 just move to here. This part, that's why they ask you this one. They gave you the partial fraction result already. You don't need to do partial fraction by yourself. So you can integrate both sides. Okay. Oh, the whole idea the green part is very natural because it's perpendicular. The green just negative reciprocal. Okay. The whole idea, just like how you solve this differential equation. We cannot do separating variable. That's why they gave you idea, which is called the substitution. It's called the substitution. Okay, I'll show you the other way because my way look too much algebra. Check we try to solve, that's the question. We try to solve this differential equation. And they gave you some idea, hint, ask you use this substitution. Ask you this substitution. That's the question. After you realize perpendicular is negative reciprocal, you just solve this one. The question just changed to how we solve this differential equation. Okay? Why we use z equals yx, x over y. Okay, maybe the other way a little bit easier. Check our way. If we don't do like the hint way, if it's possible, or we try a different substitution. Let's try a different substitution. Maybe it's a little bit easier to check. Okay, we try a different substitution. Check out. Whole idea, just how you solve this differential equation. There's no like a very magic way. This is how we solve this differential equation. In the question, they ask you say z equals x over y. It's look a little bit complicated. Let's try another way. Y equals x times u. X times u. Now, what's the dy dx? Bruce. U plus x du dx.
That's why I failed. My triangles.
If you differentiate with y with x differentiate just 1. U, no change. X keep differentiate U. That's the typical implicit of the product rule. Okay? Check out. If you got this part, everything ready. This part change to U plus X du dx. Check the other side. This Y change to X U. Y change to X U. Just X. Okay? Check out. If we can simplify it. This part, if you simplify, just negative U, 2U plus 1. Okay? And you got X du dx, negative U, 2U plus 1 minus U, 2U plus 1. Minus U times 2U plus 1. This is working also valid. You can separate variables. X du dx negative 2U square minus 2U plus 1. Oh, hello.
Oh my god. Allison, try with the slice. Did you get pasta from McDonald's? Unfortunately not. I'm quite hungry. Yeah, oh my god. Is that just your lunch?
Oh, that's from the cafeteria. It's called authentic or authentic or something.
Yeah, authentic.
Authentic. Okay.
Very cheap for students.
Oh, I have my weekend breakfast there.
It's because they give you like
Okay.
discount if you're a student. Really?
Oh, I cannot say I'm a student. Okay. Guys, next step, just totally separated. So you can do partial fraction. Okay. Both ways okay, but you need to finish it. I think maybe this type of substitution a little bit easier than the original one. Original one okay. Original one okay. The whole idea is we try to separate U and X or variable. Okay, Raymond, okay? Sorry, okay? Question, why we can do this? Because this type of differential equation, if you learn more in mathematics, of course, not in A2 syllabus, it's called homogeneous. Homogeneous.
Oh, cool.
Yeah, it's like a homo. Okay, thank you.
What about me? I'm very hungry.
Okay, homogeneous. Guys, okay? Do you need a microwave?
No.
Okay. Check out. This is the scholarship question, but we didn't finish it. Next step, just change to a typical A2. You just do partial fraction, okay? Okay, Ken? I'm happy about today. Today much better than last week. Nobody talked. That's good. Because we have too much to learn today. After this differential equation thing, this differential equation is officially in further math. Cambridge, okay. Oh, that's why my further math student always got the scholarship exam good result. Okay, now it's time to check complex number.